Hello guys, welcome to this new video. This video is about permutations. So quickly let's go over the definition. Remember that a permutation is just an ordered arrangement of r distinct objects taken from a population of n. Remember that this is the notation, or sometimes you can write, you can find NPR. It's the same thing, it's just about, the difference is about notation. And this sign NPR, or like this, NPR, is just going to mean this. So before we go over permutations examples, let me talk about, very quickly, about factorials. Remember that n factorial with this exclamation mark is the same as n times n minus 1 times n minus 2, and we continue to subtract 1 all the way until 2. You can go all the way until 1, but if you include the 1 or if you don't include it, it's the same thing. So 3 factorial is just 3 times 2 times 1, which is 6. 4 factorial is just 4 times 3 times 2, this is 24. So as you can see, when we increase 1 in the factorial, the result increases very rapidly. So some calculations with factorials become very large. Some of the times your calculators won't be able to compute such big numbers, but don't worry. So now let's take a look at this example about factorials. So assume we have 4 books in a shelf. So in how many ways can we order those books? Well, the first place in the shelf can be solution, just one. Can be taken by any of the 4 books. The next place can be taken by 3 books because we already placed 1 in the first place. For the third place we can only have 2, and for the last place we can only have 1. So the answer to this problem is 4 factorial, which is 24, right? Very easy, very easy. The same thing happens with everything that you can arrange in different orders. Remember our birthday example. The first option for the birthday could be any of the 365 days. If we don't want repetition, then the next birthday must have 364 options, one less than the first one, and so on. So if we had 365 people and we were going to ask 365 people for their birthdays, then we would have 365 factorial options of writing all of their birthdays. But remember just this thing, factorials. They are a big part of permutations. So now, suppose that 10 friends are graduating from college and they want to take one last photo as students. So they want, some of them want to be next to some others, but it seems that they have a little bit of problem. They can't organize themselves. So the photographer offers to take as many pictures as they want so they can switch places and there's no conflict. But the only condition is that they are aligned next to each other. That means that they have to be lined up like this. Here we have the first person and here we have the second one, and like that. 10 friends. We don't allow for photos where we have people in front of each other. We only allow, the photographer only wants pictures of them aligned like this. So the question is, how many different photos are possible arranged in this way? Well, the solution is somewhat the same as the book problem. Let me move this just a little bit up. So the first place can be taken by any of the 10 friends. the second place can be taken by any of the friends minus the one that is in the first place. So that's 9, the same thing until 1. So the answer is 10 factorial. So let me do a quick calculation to see what 10 factorial is. Oh, that's a very big number. This is 3,628,800. 3,628,800 different photos just with 10 people. So if the photographer knew a little bit about combinatorial analysis, he wouldn't make that offer. But well, this is the answer for this problem. So that's it with factorial. Sorry. So let's get back to permutations. So remember that in permutations the order is super important. So imagine that you have been asked to judge, sorry, this I misspelled this word, it should be judged. So imagine that you have been asked to judge an art contest with 15 entries. So the question is, in how many ways you can assign the first, the second, and the third place? Well, of course, I don't want you to do it by hand. Use your computers, your calculators. So, of course, we're going to do something like this: 15p3. Because we have a population of 15 entries here, and we have to assign just 3 places, the first 3 places. So that's why we have 15p3. So if you compute that in your calculators or in Excel or in any tool that you want, you will end up with 2,730 different ways in which you can assign the first, the second, and the third place. So please have in mind that even though this is a very simple procedure, it's a very powerful procedure. If we do not have permutations in our toolbox of counting, then we should write something like this. Let's say that each number represents one of the entries in the art contest. So then we can say that number 1 won the first place, and this is the second, and this is the third, or this is the first, this is the second, and this is the third, or this, and this. So we will not end, never. So even though computing permutations in calculators in Excel is very easy, it's a very powerful tool. So please have in mind that the population comes first in the syntax, and then the sample. So that's it for permutations, guys. I hope that it's becoming clearer and clearer each time. So thank you, and see you next time.